Hi guys, welcome back to our math tutoring class. And my name is Peter Sitokwa Jr., your math tutor and an instructor at the University of Liberia. In this lecture, we want to look at derivatives of trigonometric functions, finding the derivative of a trigonometric function using the first principle of derivative or using the definition of derivative. So you can either call it a first principle or the definition of derivative. So to do this now, let's kick start. We have the function f of x, which is equal to cos of x. So whatsoever we see f of x, we're going to replace it with cos of x. So we also need to replace this f of x plus h. So we can find it from right here as well. So we rewrite the same f of x equals to cos of x. But this time, since we need x plus h, we take this x from there and we can say let x equals to x plus h. So we can replace this x now with x plus h. We do the same on this side, x plus h. So it means you have f of x now, and you also have f of x plus h. So we now put it in the problem. We have f prime of x is equal to the limit. Anyway, we see f of x plus h. Let's write it first. Minus f of x all over h. H approaches 0. So this now is equal to the limit. F of x plus h is just cos of x plus h. Minus f of x now is just cos of x. Divided by h as h approaches 0. So our goal now is to first expand cos of x plus h. And according to cosine of a sum, cos of x plus h is just equal to cos of x times cos of h minus sine of x sine of h minus cos of h or cos of x. Now mind you, these variables x and h are dummy variables, so it can be a plus b, it can be x plus y, but this is the expansion. So if it was x plus y, it means this will be x, this will be y, and that's it. That's it. All divided by h as h is approaching 0. F prime of x is equal to the limit. So again, like we did in the previous problem, our objective is to ensure that we utilize these properties. So we think of how we can group again. So we look at this term, and this term has nothing in common. This term and this term has nothing in common, but the first and the last has something in common, which is cos of x. So we group them. Minus cos of x minus sine of x sine of h. So we can decide to take the limit of the first expression, but we can factor out cos of x. So we'll be left with cos of h minus 1 all over h as h is approaching 0. Then we take the limit of the second, the limit of sine of x sine of h all over h as h is approaching 0. So this time what we want to do is we want to ensure that we utilize these properties. So if we look here, cos of x, x is not the variable in this problem. The variable in this problem is h. So x attached to this cos makes this cos of x to be a constant. So we can factor that out. So cos of x is factored out. You have the limit of cos of h minus 1 all over h as h approaches 0. So this whole thing now, according to the property, is just equal to 0. So this is cos of x times 0. So this whole thing cancels. Minus, also, sine of x is a constant. So we factor it out. And we're left with a limit of sine of h all over h. So according to the squeezing theorem again, this whole thing is just equal to 1. So a sine of x times 1, which is now just equal to sine of x, or negative sine of x. So this is how we find the derivative of cos of x using the first principle of derivative. Thank you all so much for watching. See you next time.